as Gen 3 had said, this is the cat factory. I mean the hash cat factory. So the first link, if you do want to follow live with the presentation, you can go to that. And then the second link is where the slides will be afterwards, and it'll have my speaker notes as well. But for right now, they're turned off. All right. I did want to do a shout out. Blue Lotus is the person that made this logo, and I think it's dope as hell. It's using my company's logo, and then Hashcat, and she made the Hashcat logo, and she made everything else. So I think it looks awesome. So I just wanted to give her a shout out real quick. Oh, sorry, Blue Lotus Tech 03, not Blue Lotus. All right. So essentially, who am I? I've had IT experience for 5 years. People always talk about how many years of experience they have, but that doesn't always mean that you actually are doing fun and enjoyable things. So I have, I've been doing some really fun things for the past 5 years here at Secure Ideas, which is where I work. And while I work there, I am a pen tester, operations person, and developer, pretty much in that order as to my time allocation. So that's where I work. And some community. Professionally Evil is the open moniker for Secure Ideas. And then 49 Security Division is where I kind of gotten my start at for security. And just wanted to give them a shout out since they're in the Charlotte area and helped keep this thing running back in the day. And I mean, all the people running it now are 49th, or previous 49th people at least. So just wanted to give them a shout out as well. All right, so an overview of the issue is whenever it comes to password cracking servers, the stability can sometimes vary. I had a conversation with Netmux, the person who created the Hashcrack password cracking manual book. We were talking at a B-Sides a couple years ago, and we were both talking about how fragile cracking servers tend to be. It could be from a variety of reasons, that the operating system that you're using has updates that end up breaking things, or there's a kernel optimization that ends up getting patched for some reason. There's Nvidia upgrades that go awry or just don't work properly with your GPUs that you have in your system. So one of the examples specifically for Kali that I've dealt with in the past is that they released a package of OpenVPN 2.6, which ended up breaking quite a few people's configs because there was a breaking change in it. They ended up rolling it back, back/forward, because whenever it comes to semantic versioning, you have to go forward for it to pick up the new image. But they rolled that change back. But I can't really blame them because they're based off of Debian testing, so Debian tests things with that operating system. So it's just something to be cognizant of and making sure that you have a plan in case that does happen. Nvidia drivers, the ones that I've used whenever I've been using Kali for the operating system to run Hashcat, those have been really stable overall, but they don't have the most recent versions. So the links for the Nvidia repos, how to set it up, and the actual repos themselves are down at the bottom. If you're at the live presentation, you can actually click on them to take you to those pages. You'll be able to get the links to this afterwards anyways as well. But shout out to Travis, one of my coworkers. He told me about the blog post, and it's a really streamlined way for you to actually have like Debian or RHEL-based distributions and be able to get really up-to-date releases of the GPU drivers. So the one thing with that is that since you are getting it from upstream, that means that you're not getting as much testing as whenever you have them coming from the actual repository for the operating system. That's what those stars are for, because you're essentially wading into a beta testing area of using their Nvidia drivers. So there might be upgrades or incompatibilities that end up screwing things up. So you are warned. So next thing is what happens whenever you need to recover and you're using a bare metal machine. Hopefully your computer doesn't look like that, but whenever you're using a bare metal machine and there is some type of operating system upgrade that goes awry, how do you have a backup or a restoration process so that we can get back to a working state? And crossing your fingers and just removing the package does not count in my book. Although I have done it plenty of times, it's not what I would recommend. So the next thing specifically for me while I've been working at Security is that I've been a remote employee my entire tenure here. And whenever there's a server that is in Jacksonville, Florida, it is a little hard for me to access it from North Carolina whenever I don't have some type of remote management interface or IPMI. So I typically ended up having to DM one of my coworkers and say, hey, can you turn the server on and off again? So this was a frequent situation that I had to deal with whenever I had not implemented the solution that I'm going to tell you about, because the server that we had ended up just crashing like at least once every month or every 2 months. And even with me looking the logs and trying to determine what was going on, I still could never really figure it out. After I'd implemented what I'm about to tell you about, I think we've maybe had one crash in the past 2 years. So it's been working pretty well so far. So one thing that you probably don't think of is that I'm going to be using this new technology that you've never probably heard about. It's called virtual machines. Okay, all right, maybe you've heard about them. Even though they're a really tried and true technology in the industry, and they're not really fancy or containers or anything like that, they actually work really well, and they help give you that level of separation between your actual host and the kernel that it's running, which in this specific instance is very important. And I say, well, kind of, because we're actually bridging host technology into the actual virtual machine. So we'll get into that a little bit later, but I've got a diagram to help kind of explain things. But essentially, we are using the virtual machine to help be like a more thick isolation layer between the actual kernel modules that get installed for the GPU drivers and the actual host, which means that we can leave the host be pretty much vanilla OS. So I'll go ahead. These are kind of the overviews. In the speaker notes, I actually have links for all of the hardware for our old system and the new system. The new system just times 2 that because we ended up getting 2 of them. But from a hardware perspective, there's kind of, we're not going to cover a lot about the hardware. We're mainly going to be covering about the software. But there are some things that you need to make sure that you have if you do want to implement this solution. One, your hardware needs to be able to support virtualization technology, which, I mean, pretty much all hardware does nowadays. But just want to make sure you know. The other typical best practice is that however much video graphics RAM you have, you typically want to have that much actual RAM as well. It allows the actual like caching of the file system and loading of word lists and other things like that to really not be as much of a bottleneck as if you were more RAM constrained. Another important thing that I didn't know about until one of my coworkers had told me about it, who had built the original cracking machine that we had, was that there's actually a very specific style of GPU that you want to use whenever you are building a cracking rig. And the reason why is most of the third-party gaming cards end up having fans on top, which whenever you're trying to stack as many GPUs together, doesn't allow you to have any breathing room for them to actually cool off at all. So the style of GPU that you want to use is called a blower style, and it actually causes the air to gets sucked out the back, and so that way it allows hot air to escape the machine instead of getting bounced around inside. So small detail, but really important to make sure that your hardware lasts as long as it can. One of the other things that I initially didn't have, and I was hell-bent to get it whenever we got these new servers, was some type of remote access. So IPMI is typically the one that a lot of people know, or iDRAC, or whatever the other ones were. But they are lifesavers because you can essentially reload an entire operating system remotely. And I did that quite often whenever we were benchmarking different operating systems for this setup and different types of setups and stuff like that. So it was imperative for me to be able to not be hampered by having to wait for one of my coworkers to go install an operating system. I could just reflash the entire operating system myself. So that was really helpful. So moving on to the bare metal OS, we ended up settling on Ubuntu because you don't want something that's too bleeding edge. You want it to be a bit more stable so that way you have a solid base. And whenever you have more bleeding edge operating system, or typically, in general, whenever I say operating systems during the presentation, I'm talking about Linux, not Unix, because FreeBSD has specific requirements that are not really easy to satisfy for this, so I'm specifically talking about Linux. So you don't want to do too bleeding of an operating system because they actually can end up running into errors and issues with actually passing through the physical hardware because of the kernel modules needed. So you want to typically prefer something that has an LTS cycle or a long-term support, so that way it allows you to have kind of that buffer and let other people be beta testers while you're still running your actual cracking rig. Yeah. I didn't realize that there was that much of a difference in cooling solutions for GPUs either, Titan. And my coworker actually ended up finding out about it because of going to the Hashcat forums. And he just asked for guidance. And that was one of the big things that he said that was really important. The bare metal OS. So prefer something that has a long-term support, so that way you can continue to run your actual cracking rig without issues, or without as much issues. Also, you don't want to have something too slow, because then you don't typically get as many kernel optimizations and support as much newer hardware whenever you do something that's a lot slower. So we chose not to use Debian specifically for that situation. That bare metal OS is going to end up being your fallback mechanism if the VM does ever actually fail. So it's really important to make sure that whatever you're using for that will just continuously run without issues. So for the cracking OS, we ended up settling on Kali, mainly because we're just doing like a minimum viable version of Kali. So we're using a specific image that I actually make. It's a Vagrant image that's hosted on Vagrant Cloud, and it's actually just installing SSH, and that's it. It doesn't even have Vim in it. You have to use Vi without having to install Vim. So it has no desktop, it has no offensive tools. The only thing it has is the VPN software that we use and the actual Nvidia kernel drivers. So it literally is as minimal as it can be. The other reason why we chose Kali was that they're really cognizant of people wanting to use their machines and their operating system for password cracking. They actually published a blog that I ended up using to help develop this, the cracking VM specifically. So if I was doing a different operating system, they might not have as well-tested GPU drivers or as new as GPU drivers as Kali has, because it is more of a Debian testing, so it's more rolling than a lot more long-term support operating systems are. So this is kind of like the overview of the solution. So originally, whenever I was meaning kind of to the actual virtual machines before, I thought about, well, Amazon and all the other clouds have some type of GPU, and so how are they doing that? Because typically, whenever you get an Amazon EC2 instance in their cloud, it's some type of virtual machine. So this is a quote off of their website, and that's the link, and also the Wayback Machine link for it. Essentially, it's saying that while their specific hypervisor is different, which is AWS Nitro, they're actually using virtual machines and passing through host hardware to actually do GPU and performance intensive tasks. So while they may have more proprietary optimizations in their situation, they are doing the same technique that I'm talking to you about today for serving up their GPUs. So it's a tried and well-tested implementation of utilizing GPUs. So Nitro in this explanation essentially means VMs, and I linked to the Nitro page as well. So like I had mentioned, we're using the Linux kernel, and in there we're using a specific technology, I guess, or technique that's called PCIe pass-through. And so what we're actually doing is we're taking the physical lanes that are on the hardware itself, and we're passing through that PCIe lane into the VM itself. So that allows us to have a physical graphics card be fed into the actual virtual machine. And that's this specific type of technique is typically more used with network interfaces. So you'll hear of people passing network interface, like actual physical network interfaces into VMs more than hearing about PCIe pass-through with a GPU specifically. So that's the technology that we're using under the hood in the Linux kernel for this. And then the technology stack that you install for the actual operating system is libvirt, QEMU, KVM. I'm just going to refer to it as the libvirt stack from now on. Libvirt is essentially the management software around QEMU and KVM. KVM is the kernel virtual machine, so it accelerates your actual virtual machines and makes them a lot more performant. And then QEMU is the actual hypervisor itself. So originally I actually did this because I didn't want to have to install Windows on my laptop. So I wanted to play video games, but I didn't want to have Windows on my laptop. And I actually have an external GPU, and I'm able to feed in my external GPU and have it passed over USB-C to my virtual machine that's on my laptop, and I can play Windows games that way. So it's really cool, and there's actually a lot of YouTubers out there that talk about this. You can typically just search like Windows 10 or Windows PCIe pass-through video games, and it typically comes up. And then anyone that knows me knows that I love to automate things, so I couldn't do this presentation without automating something. It makes my life easier and makes the rest of my coworkers' lives easier as well, because they don't have to know what I'm doing under the hood. All they have to do is click a button and it runs the automation for them. So the technology I'm using for that is Vagrant, for actually pulling down the Vagrant box that I create from another project that I have, and then having a deterministic configuration for that VM every single time it starts up. And then the other tool that I use to wrap around that and do the actual configuration management of the system is Ansible. So that's what I use for the automation. So here's kind of a visualization of what's going on and what we'll be doing, or what we'll be displaying in the video. And if you do have any questions, feel free to ask. I realize I'm more than halfway in and didn't think about or mentioning it sooner, but definitely feel free to ask, because I know this is a dense topic, and if it's confusing at all, I'll try to answer it to the best of my ability. So this is a visualization, and the laptop here, essentially it's just there for actually running our Ansible. And then it communicates over, this is specifically what I was doing. So it's communicating over a VPN to install all of the necessary software on the bare metal server, the Ubuntu bare metal server. And from there, it installs Vagrant, it installs the VM software, so the libvirt stack. It pre-computes all the information necessary to do the actual PCIe pass-through, and then it also performs the actual PCIe pass-through with reboots in between to make sure that things are getting properly loaded. So it will do all of the minimum necessary things to actually get PCIe pass-through prepared for your VM to start up after it reboots. The other thing that I was doing, or that I'm doing, is I'm installing Hashcat on the actual bare metal server, because what you'll come to understand in a little bit later is that I'm trying to keep the cracking VM to have as little to do as possible. It is essentially an ephemeral host and can be blown away at any time, and I can restand it back up at any time, and not lose any of the information that's inside of it. So I actually install the tools that I need to compile Hashcat, and I clone their Hashcat repository, so that way I'm getting the most recent version of that. So I clone that down, install the tools for it, compile and build it, and that's all in preparation for essentially that NFS share, where it's right next to it, this part right here. So that is all the persistent data that's needed inside of the VM. So we specifically actually just wipe out the whole /root folder, not like slash as in the root folder, but /root, like ROOT. Just to clarify, we're not RM Tech RFing our machines. But we actually end up removing that whole folder, and that entire folder lives on the NFS share. And since it is just kind of a local network connection, there's not very much bottle constraint, or there's not very much network constraint there, because it's literally just a virtual interface that the device has created internally of itself. So we haven't seen any issues, at least. So then I'm also passing through the Hashcat binary itself, and I'm not doing it in this demonstration, but I pass through a VPN config and everything that's needed to get it on the VPN as well. So that way, whenever it starts up, I can actually, for my work, we just do all the provisioning over the VPN. But in this situation, we're actually going to just use the bare metal server as a jump host, and we're going to install everything that we need through the bare metal server into the cracking VM. And so that moves to the actual cracking VM itself. And like I was mentioning before, we're literally just keeping it as minimal as possible. So we've got Kali and the Nvidia kernel drivers. So we're just keeping it as lean and mean as possible. So, all right, next is the demo. Oh, let's see. Is there a reason you don't have the Hashcat binary bundled in the cracking VM? So I could install it from Kali's repos, but even though Kali is Debian testing, they actually can still lag behind the Hashcat releases by at least a few weeks to a few months. So I specifically just clone it into the actual bare metal server, because I'm doing all of the development tools. I'm installing all of those development tools inside the bare metal server instead of the cracking VM, just so that way I don't have to introduce any other types of variation that potentially Kali is gonna cause things to screw up. The other thing is that Ubuntu is known to be a really stable operating system, so the tools that are used to build other tools has to be really stable and well trodden for people to be able to compile and distribute. So that's one of the other reasons why I prefer installing the tools in the bare metal OS of Ubuntu instead of Kali. So Yeah, that's a good question though. And just to reiterate, if people don't know, is there a reason you don't have the hashcat binary bundled in the cracking VM? Is the question that Titan had mentioned. But that was my answer. Cool. So now to the actual demo. And I don't know how well this is going to work with trying to share my audio, but I guess we'll find out. Let me know if you guys can hear the audio once I start hitting play. If not, I'll just mute it and talk over it. Oh, I don't even hear the audio. What's going on with that? Oh, there we go. Could you all hear that? Or no? Okay. Alright, so I'll just talk over it then. So right now we're getting ready to start or launch the bare metal provisioning playbook. Go ahead and just try and... so this is an Ansible playbook that essentially installs all the necessary tools inside of the bare metal host. The tool we're using to run it is Ansible Navigator, and I've pre-configured the inventory for the actual machine. So it's inside of a configuration file that the inventory that I used is actually up there. The only thing you'll have to do is add the SSH config that I put at the bottom of that file in the repository. So all we're doing is running Ansible Navigator run and then the playbook. And Ansible Navigator is essentially just a nice TUI or terminal user interface that runs your playbook for you. So I'm going to mute that so that way, well, actually. All right. So now I started it and it's getting ready to start the plate or start running tasks. And before, right here, too far. This part is essentially like an overview of what playbooks are inside of this, what plays are inside of this playbook. Since we only have one play, you can actually just hit 0, indicated by the number up here. And once you hit 0, it'll actually essentially dive deeper into that playbook's output, which is what this looks like. So you can see the first one is in progress and it's just trying to gather facts. And so now you can see it says okay, and it's starting to proceed to the next ones. And the other thing was that changed will actually be true if that does change. It'll say false, or if it's blue, it'll skip. So now it's speeding up, so because this ended up taking like, I think 5 or 10 minutes. So right there, I actually switched to the typical user interface that you would see whenever you're running Ansible. It's called, or whenever you're in that UI, you can do :stdout, std out, and hit enter, and it'll bring you to that view. Ansible Navigator is actually the way that Red Hat recommends that you develop playbooks and stuff, and it's a newer technology, so it's still taking time to figure out the kinks and get adopted. Cool. But I just wanted to bring that up real quick. So this was the only 2 things that are going to change on the entire host, and that's just saying that it started the first time that it started the actual VM from this Ansible playbook, and then it's running the provisioning scripts for the VM. So that's gonna be the only things that have changed. And the reason why I did that was because, sorry, it's hard to hear myself talk at the same time. The reason why I didn't wait for an entire thing is that just for brevity, essentially, because this ends up taking a long time too. This actual video was 30 minutes long, and I'd cut down all the time in between to only be like around 4 minutes. So that's why I didn't include like a fresh host to get all of the changes and stuff like that. So now that we've started up the VM on the actual host itself, we've already got our SSH config set up to where we can use that bare metal host as a jump host and automatically connect into the cracking VM host. So that's where our Kali machine resides. So this is starting the actual provisioning for the cracking or Kali/hashcat VM. And this is where it'll go in and install the Nvidia drivers and everything else. So this one's going to have a lot more changed is true because it's a completely fresh VM. I had destroyed it before running this playbook just to make sure it was completely fresh. So you can see that I'm installing different software. That was actually an FS client. And then I'm mounting NFS shares, and then didn't have to upgrade the system because it's a fresh image. We reboot to make sure that if it was updated, it has the most recent kernel information running. Then we blacklist the open source Nvidia driver Nouveau, so that way it doesn't conflict with Nvidia's kernel driver. And then we reboot to make sure that the Nouveau driver is no longer loaded. And this is the part that takes a long time. There's only 3 packages that Kali says to install, but it installs like a crap ton of information. You can see it took around 8 minutes or 7 minutes. So now it's kind of just some more niceties and stuff like that on top of what we've already installed. One of the last things I end up doing is adding a hashcat wrapper, so that way my coworkers can just type hashcat, and it essentially just executes the executable that's in /op/hashcat, just to make sure that I don't conflict if for some reason they try to install hashcat and it doesn't wipe away the binary that I have there and stuff like that. So the other thing was that apparently one of my coworkers said that HC used to be an alias for hashcat, so I just sent link to the actual wrapper. So you can see down here it says successful, so that shows you that it was successful. So this is us connected to the actual cracking machine, and this is how you can check to make sure that your Nvidia driver has been loaded properly. And you can see what processes are running, so if hashcat was running, you would see it there. And then that hashcat I command shows you all of the backend interfaces you can use to crack passwords with. So these are the different GPUs that we have. So this was our old server with the Nvidia GTX 980s. Well, get out. There we go. Okay. All right. So that was the demo. And the actual code that I use for running everything is up here. I'll just go to that real quick. I use VS Code to develop it, if you didn't notice that from the video. And there's a specific way that I typically pin my Python dependencies. So I've got some special configurations set up, so that way, if you want to do the same thing, you can just do the exact same way. I'll work on getting a README in here. As you can see from the timestamps, it was a little late to the game to getting everything together. But these are the playbooks that we ran. Testing playbook is just there to check and make sure that you can make connections to the actual machines before you actually run each one of them. And then bare metal playbook and cracking VM playbook is what we already talked about. So this installs all of the stuff for the bare metal machine. And this actually has a bunch of my custom Ansible roles that get installed from Ansible Galaxy, which is like the hosting provider for Ansible packages. So it installs all that stuff, installs Vagrant, Hashcat, does the PCIe pass-through for you, and has a template that comes with it for the Kali VM. So that way it dynamically grabs how much memory is on the host and gives about 80% to the VM, and takes all of the CPU cores that you have and subtracts 2 from it and gives all of that to the VM. And we'll get into this is technically one of the drawbacks of it as well, so we'll get into that in a second. Cool. So, comparison for running a bare metal host versus running the way that I'm mentioning how I think you should do it. There's a slight performance overhead because there is that virtualization interface that the machine is having to pass through. But overall, we didn't really see very significant results from that. There was maybe 1,000 or 2,000 mega hashes difference, which it really wasn't that much of a difference, even though it sounds like a lot. We were typically getting either the tens or the hundreds of thousands of mega hashes per second. Between 5 mega hashes is not that bad. So technically it is more complex because there's more moving parts. So technically there is more complexity. I do think that the automation helps offset that a little bit, but I wanted to bring up the negatives in case this isn't something that you're familiar with or you're comfortable with. The other thing, which is the one negative that I really hate about it, is that all of that compute ends up getting reserved for the actual VM. So on the host OS, it seems like it's constantly running at a high utilization because all of those resources are reserved and passed to the actual virtual machine. So while it sucks because it makes your machine run at a little bit higher, it's just it helps make things more reliable, like I mentioned below. It helps whenever you have to manage more than one server at a time because we're using the automation. So I actually manage 3 password cracking rigs right now, and I just run the same playbooks across all of them. One of the small things, but very important things that you didn't really see here was that in this PCIe pass-through playbook, there's actually a string based on your processor. So just very quickly, if you have an AMD processor, it's different than an Intel one for what that string needs to be. So slight difference, but as long as you know that and set it accordingly, then it'll do all of the work for you in the background. So the other thing that this brings is that it brings versatility. So if you did end up wanting to using one of the machines for ML or any other type of GPU intense task, you could essentially just spin down the cracking password, the password cracking VM, and just spin up a new VM with all of the information or all of the tools that you need for that task. So it helps that system be quite a bit more versatile versus it just being installed and potentially having to manage with all of the complexity and difficulty of all being on one system. So those are the positives in my thoughts. Have you tried running it on AWS / had any problem with cloud anti-fraud? I don't know about the last one, but I did look at a few talks about what running it on AWS would look like. The issue becomes, because it's someone else's infrastructure, is that you're billed per your usage. So there's quite a few times where we'll just let our password cracking machine keep going at hashes because we don't really have any issues with letting it continue to run. And say it takes 5 days for it to crack a single password hash, but that one hash ends up being the admin to the entire network, or domain admin's password or something like that. You then have to start weighing like what value do you get out of running your resources continuously in AWS versus the amount of money that you're going to end up getting charged, which makes things a lot more complicated. So from our perspective, since we already had a password cracking rig before, it was easier for us to justify because we've seen the returns of having a machine that we just let things run on and it ends up cracking passwords and ends up being really useful. And since we have 3 now, it's been really helpful that we've scaled that out a little bit. And we're actually looking into ways that you can run things in a bit more distributed. There's actually a web UI that you can use called Hashtopolis. And I haven't gotten around to actually installing it and using it for us yet, but I have messed around with it. I actually contributed the Docker Compose file into the repo because whenever I run that, I wanted to, since it's an actual application, I wanted to have it containerized and isolated. So there's other ways that you can kind of distribute work, which if you were running in AWS and you could spin up maybe a bunch of smaller nodes, but have a lot more compute because you're doing more, it might work out better. But it's always just a balance of like, how much can the company justify letting that continue to run versus how much money they're going to get billed. So us having the physical infrastructure that we can invest into up front will then pay dividends in the long term because we don't have to worry about, the only thing we really have to worry about is electrical bills at that point. So for us, I think that answers the question, but that's why we don't run it on AWS. And I will say, running on AWS, from what I saw, running it efficiently on AWS takes a lot of glue because you end up having to kick off a queue for a password, and then that spins up a machine, and then that machine pulls that password to crack to its system, and then after a certain amount of time, there's another thing that kicks off a stop to tell it to stop, and then if it ends up not cracking the password, it's a whole lot. So to run it efficiently on AWS requires a lot more automation, at least from what I've seen. So that's something else to consider. Have you ever had a situation where you have multiple engagements where you have to run multiple cracking VMs on your system? So we typically end up doing one bare metal host per cracking VM. And the reason why we do that is so that way we can give it the most amount of resources. Because even if you spun up 2 VMs with the same amount of resources each, it would still effectively be the same amount of resources overall, because it's on the same shared host. So we have had multiple engagements where we're running, well, we always leave all of the servers running. That's just connected to the VPN. So we have 3 of them, and all 3 of them just stay connected at all times. And then any consultant that needs to crack a password just SSHs into them and does the password cracking. So, but very good question. If we were more distributed, I think, like if we had a lot more smaller machines or something like that, then I think what you're talking about would come into a little bit more play. But yeah, he followed up with, gotcha, that makes sense. I was curious about scaling on individual bare metal, but that makes sense about the resource dedication. Yeah, just so that way we can essentially get the most bang for the buck for that cracking machine. I know I have 1 more minute left. Does anyone have any other questions? Awesome. I didn't put a link to my stuff, but if you want to get in touch with me, I'm just elrey.casa/me. I'll put an HTTPS because Discord doesn't like my domain. That takes you to my bio where it links out to all of my different stuff. That's also where my blog is at, so if you're interested in that, You can go there. I have not blogged about this yet on my company's website or my company's blog, but I do plan on giving a more detailed, yeah, that too. There's the slides. And I'll make those the presenter side or the speaker notes available as well whenever you go to view them. So yeah, I think that's everything then.
Thanks so much, elrey.
Awesome. Stop that. Cool. Thank you for having me.
Anytime.